In this lesson, we're going to find the cube, fourth, and fifth root of variables. Perfect square root variables. Well, recall that for square root, you don't see an index outside, but it is assumed that the index is 2, so you're dealing with square root. So if you have the exponent that the variable is raised to, if that number is divisible by 2, then it is a perfect square. You can easily identify a perfect square variable because if the exponent of the variable, if it's divisible by the 2, the index, then it is a perfect square. So in the first example, what's the square root of x squared? Well, the index is 2, and since 2, the exponent of the variable, is divisible by 2, then it is a perfect square. So 2 divided by 2 equals 1, so the answer is just simply x. Moving on to the second one, again, the exponent of the variable is divisible by 2, the index. So 6 divided by 2 equals 3, so it equals y to the third power. One other way you can look at these, if you don't want to divide by the index, you can just take the exponent of the variable and just say what's half of it. For example, here you have a variable m to the 10th power. What's half of 10? Half of 10 is 5. So this is going to equal m to the 5th power. All right, so let's try the last three on your own. What is the square root of r to the 16th power? If you said r to the 8th, that is correct. What is the square root of t to the 12th power? That's correct, t to the 6th power. Last one, what is the square root of s to the 22? You got it, s to the 11th. There you have it. Perfect square variables are those in which the exponent is divisible by 2. Let's move on to perfect cube variables. So you know that it's a cube root because you have an index of 3 on the outside. So if the exponent of the variable is divisible by 3, its index, then it is a perfect cube variable. So let's look at the first example. Notice that the exponent of the variable is a number that is divisible by its index, so therefore this is a perfect cube root variable. So what is the cube root of y to the third power? All you have to do is divide it. 3 divided by 3 is 1, so therefore it equals y. Let's go to the next example. 6 divided by 3 is index equals 2, so the answer to that is x squared. A to the 15th, since 15 is divisible by 3, the index, so the answer is what? Yes, a to the 5th power. What is the cube root of x to the 18th? Yes, x to the 6th. What is the cube root of x to the 24th? Yes, x to the 8th. What is the cube root of x to the 33rd power? Yes, x to the 11th. There you have it. Perfect cube root variables. You know they're perfect cube roots because the exponent of the variable is divisible by the index of 3. Moving on to fourth root variables. You know it's fourth root because it has an index of 4. So the variable, the exponent of the variable must be a number that is divisible by 4 in order for it to be a perfect fourth root variable. What is the fourth root of x to the fourth power? Well, we divide the 4 of the exponent by its index of 4. 4 divided by 4 equals 1, so it equals x. Also recall the rule of whenever you have the index is the same as the exponent that the radicand is raised to, that is always going to equal whatever the radicand is when it's a even root. Notice that rule. All right, moving on. What is the fourth root of a to the 12th power? So let's go ahead and divide our exponent of 12 by its index of 4. 12 divided by 4, so the answer is a to the third power. What is the fourth root of x to the 24th power? Yes, x to the 6th. What is the fourth root of z to the 28th power? Yes, z to the 7th. What is the fourth root of m to the 36th power? Yes, m to the 9th power. And lastly, what is the negative fourth root of y to the 48th power? Careful with that one. Well, remember when you have a negative on the outside of the radicand, you're going to negate your answer, so it would be the very opposite of what it would be in terms of the sign. So yes, that's going to equal negative y to the 12th power. And there you have it, fourth root. Fifth root variables, you know they're fifth root because the index on the outside there is 5. And if the exponent of the radicand is a number that is divisible by 5, then it is a perfect fifth. So what is the fifth root of x to the 15th power? Yes, x to the third. What is the fifth root of x to the 25th power? Yes, x to the 5th. What is the fifth root of x to the 40th power? Yes, x to the 8th. What is the fifth root of x to the 45th power? Yes, x to the 9th. What is the fifth root of x to the 55th power? Yes, x to the 11th. And lastly, what is the fifth root of x to the 60th power? Yes, of course, that will give you x to the 12th power. And again, there you have it. Perfect fifth roots in terms of the variable is where the exponent of the variable is divisible by 5.